Before we create our template, we want to know what HTTP headers are being used in the communications with the HTTP server. Some custom HTTP servers often use extra or unusual HTTP headers, which might also contain vulnerabilities. We can quickly review the HTTP headers used by capturing some traffic with Wireshark while browsing the HTTP server. I'll quickly open up a previously captured session in Wireshark, and we'll start building our Spike template. So this was our request. This was a valid request made by a browser. So let's copy this and use this as a template for our fuzzer. Let's start with the first line, the GET request. We want to replicate the GET request in the Spike API. We can do this by using the following syntax. Before we continue, I'd like to comment out all our notes so that when we try to run this file within Spike, it doesn't complain of any syntax errors. So effectively what we've done is recreate the initial GET request using the Spike API. However, as it is now, we won't be fuzzing anything, as we haven't set any fuzz points yet. In order to set a fuzz string for this example, we could use the s_string_variable function. So let's quickly edit our template to include some fuzz points. Spike will now send a GET request with the following parameters, and each parameter in turn will get fuzzed by appending different buffer lengths and buffer types to our string variables. So let's quickly try to run this and take a Wireshark dump as we're doing this in order to better understand how this fuzzer works. We'll invoke our fuzzer by using the generic _send_TCP utility. And let's give the host IP and the host port of the target that we are fuzzing. And let's call our HTTP template and start fuzzing from variable 0, instance 0. Now we're not really interested in crashing anything just yet. We're just trying to get a better idea of exactly what it is that Spike does. So let's open up Wireshark. And sniff on TCP port 7510. So while our sniffer is running, let's run our fuzzer and just capture a few instances of fuzz requests in order to better understand how this fuzzer works. Alright, so we've sent approximately 26 requests. Let's try looking at a few of them in the Wireshark dump. And remember that we are fuzzing the first variable. We could see this here. This is the variable number that we are fuzzing, and this is the instance in that variable. So let's take a look at this packet. Wow. So as you can see, our GET request has automatically been changed with this wild buffer right here. And these buffers change and are editable within the Spike source code. So let's continue writing our Spike script. And in order to save some time, I've already made some modifications. Essentially, all I've done is I've added the host and the user agent headers, and notice that I've removed some fuzzing points. Essentially, we'll only be fuzzing the host header, simply to save some time and traffic for this demonstration.